Hello and welcome back to Introduction to R Programming, Spring 2019, module number 2. In this module, I'm going to talk about data, but I'm going to look at that in the context of functions, vector, numeric, string, characters. So those are the things that allowed us to hold a set of data, a container of data, in order for us to start sorting them out, start to apply the logic or the syntax of our programming. I'm going to go over basic stuff, how to import data to R, but I would like to start with computer organization. And the reason for that is that, again, in the back of my mind, as I learned about computer science and programming, we learn about the logic of the units of computer system. We talked about input unit, we talked about output unit, memory, the logic unit, the processing unit, and the secondary unit. With regard to the secondary unit, nowadays when we talk about storage, we are talking about the clouds, and so as a result, our devices look much smaller than we are accustomed to seeing from the past. Um, we are also experienced the evaluation of how the processing is being done, and from one task operation, nowadays we are going for stimulus operation and tasks that our phone are able to do today. And so again, the issue of processing is a real component of what makes the computer such a success in today's environment. A little bit about the history of computer. We have to talk about that. 1977, Steve Jobs from Apple and created the first introduction, but in reality, in 1981, IBM introduced the first off-the-shelf components of the IBM. But in that context, we also need to remember that there were two type of languages: machine language and assembly language. And machine learning was instruct to give numbers, giving machine specific instructions, do this or apply that. And assembly language was more like abbreviation of English. So we would do things that the assembly language was not able to do, such as load the data or add row of data or store the data. And by doing that, it will allow us to have a higher level of impact with that regard. So the issue with regard to the assembly language, it usually allowed us to use mathematical notation through a compiler in order for us to execute them. Example, if you go back or you remember the DOS, or if you are running a server, if you say gross pay equal base pay plus overtime time pay, you will have some set components that the application will recognize in order for it to run the data set and to apply to it. However, this is only the formation. This is only the language, or the idea of the language that be applied to. But in the long run, those languages consist of Fortran, COBOL, Pascal, and probably most of you already know about those type of language. But in the idea of the syntax, or idea of the code and the syntax, is the idea that we have objects that are allowed us to have data object, time object, paycheck object, invoice object, in order for us to apply to this. So the programming language and the assembly language and the machine code will be able to recognize, to be able to understand. Okay, so with that short introduction, I would like to start with the object that contains some set of data that allowed us to apply or to calculate the idea of R. In comparison to any other application, statistical application, such as Excel, such as SPSS, the idea of the data itself is part of the object, and we retrieve the object by applying different techniques, and you will see that how we do that in order for us to simplify it and to take the data out of it in order for us to do the calculation. So the first is the idea of an object is when we are typing A and we call that the container inside A is equal 1. And so in this case, the A is equal 1. We can add to this object A, we can add more numbers and even text. And I will talk about text later on in this podcast, but that's the idea of an object and the idea of what it will hold. All our textbooks talks about good names versus bad names to the object, and they all recommend that make it short, make it concise. Do not use the $ or bad names that you will not remember, because otherwise it will cause problems later on when we will start writing not 1, not 2, not 5, but more than 60 or 70 lines of code. We want to make sure that we have very clear understanding and the R machine has a good understanding what is the object that we are using in order for us to do that. So let's start with the first thing that we're going to cover in this class, function. And it is the issue of the idea of what is it called. And function is part of any programming language. If you have experience with JavaScript or with you did other courses in other languages such as C++, you will know that there's the issue of function. In R, we have already embedded functions that already embedded into the RStudio. But we can also create our own function and again give it a name, and it will be able to do that. Example for a function is the calculation of the mean. The mean is the average. And so when you're using a function in a very simple way, you will say, okay, mean, and I will hold a container that will hold data set, in this example 1, 2, 4, and I will ask the R to calculate. But I can add to this function a little bit more, which means I can add to the function more pragmatic calculation and ability to apply to it in a sense that it is cover the factorial function in this example. And so in this case, I will say what is the mean, and the second one I will say factorial. I will define what is factorial for the R and ask them to calculate, and he will do that. And again, this is the idea. R provides us a lot of functions that I gave you. There's a short list of function and the long list of function. The craneproject.org is where all the syntax and all the programming language you need to know about the R. It's also where you're going to store your package in the end of the semester. But with regard to the functions in R, there is a list here that consists of 3 pages or 4 pages that list all the functions that already been known to the R, and it is a default functions, and hopefully you will be able to remember that in order for you to do that. So let's take an example. And function can, again, one of the things that I would like to repeat is that a function can work with another function in both directions, and by doing that you can have a much more productive arguments in that. So the function provides us an argument in order for us to do that. Example, mean is a function, and if I will set the data container will be 1 to 6, And then I will say I want another function that will run into this calculation, and I'll say the mean. He will come back to me with an answer. So I have two functions in one data connector container that will do that. We can do that in other forms, but for now, that's what I will show. Also, the idea of a sample. I know that some of you took the introduction to statistics. Some of you already know statistics. So the idea of a sample is the idea of taking from a population a sample that represents the entire population. And so the idea here is that in the R, we can take a sample that is defined by the object that is in this case C. The size that I want to have the sample is 2. With a replacement or without a replacement, I can define it for the R. In this case, I can say true, or I can say I don't need the replacement or without a replacement, and I will not refine it. But it's up to you to decide how you want to pursue your writing of the R in order for you to apply. In this case, I defined it as true, and in this case, it is with a replacement. So I lay out for you with a replacement and without a replacement. Potato snacks is usually a pure example of how any statistical professor teaches this idea. If you're not familiar, this is a good slide I want you to go over. I would like to continue with the idea of R. And the functions in R are a first-class object, which means they are treating much like any other R object. And by doing that, we have to have, the function has to have a name, a body, and a set of arguments to make your own function. You can replicate those parts and store it in R as you like. So the function's a name of arguments has potentially have a default value. So the format of the arguments are the arguments including in the function definition. And the function argument can be missing or might have default value. Again, it's up to you to decide what are those values. Example, normal distribution. And normal distribution is the idea of every statistical class is covering the central limit theorem, and it is part of any statistical classroom. In this module, I'm going to discuss normal distribution, and I will elaborate more later on in the semester. So the functions in R, and this is where the beauty becomes into it, is that we have normal distribution, we have probability distance function, and we have cumulative and quantitative function inverse of P norm. And all of that has to have a syntax that will go with it. Example, the n, the mean, the standard deviation, or any other things that the command that you ask the R to perform needs to have in order for it to operate. So the normal distribution has two elements that needs to be entailed: the mean and the standard deviation. And the idea here is that if we will take an example of a textbook that usually distributed with a mean of 100 and a standard deviation of 16, the length of a textbook produced before 2008 might be with a mean of 280 with a standard deviation of 10. Again, the issue of the family of normals can be standardized with a normal with a mean of 0 and the variance of 1, and we can achieve that by using the following formula: the z-score equal the x minus the mu divided by s, and in R code, and when we do that is the R normal, and again the 1, the 106, and I apply that in order for us to calculate and see what it is replaced. And we can also display that in histogram, where I lay out for the R to recognize what type of visual I want to display. In this case, it is HIST, which stands for short of histogram, with X, with the probability is true, and color gray, and the main, and I will set up the premises of my visual in order for me to display this. Okay. We talked about functions. Now we need to go to another type of data container, which is the vector. And it is hold a sequence of data elements at the same type, which means that the value of a vector may contain 3 numeric values of 2, 3, and 5. And we can convert those values to a logical values. When I talk about logical value, I'm talking about true or false. And so if I will play with that, and I'll create, example, a vector can contain a string. A string is a text, not a numerical value. Again, it can be converted into vectors with regard to true or false, and be able to identify them in order for it to apply. And we have the idea of indexing of a logical vector. And again, this is where we try to sort what is true or false by using an index in order for us to apply. So this is the syntax of the R with regard to vector and indexing vector, and how to apply to it. We can also modify the vector, and we can modify it throughout the process and by identify again. In this case, I started with the first line, the X, and I have a container of the data. I can modify the second element in the container, which is the minus, and I can give it a value. In this case, I will set up the value. In this case is 0. And so modification of the container allowed me to follow up on it and be able to see the result of my modification. We can also delete the vector by assigning the null to it. And again, in this case, if it's null, it will not come up through. Another form of a data container is a matrix. And a matrix usually contain additional attributes of the data. Usually we are displaying a matrix in 2 rows of data. So in this case, all the attributes of an object can be checked with the attributes of the function and the dim functions of it. So let's look at that. A is a matrix, and I can define what is the content of my container, and then I can define how many numbers in the row, how many numbers in the columns, and fill the matrix by row, and allowed me to display this. So again, the issue of a matrix is another way for us to sort the data. One of the biggest problems with Excel or SPSS, and when we have a large set of data and it doesn't make any sense what we are seeing, the issue of R is make it simple by using matrix or using any type of organization of the data to sort the data in order for us to understand it. Another form of sorting the container is a list. And a list can have a lot of advantages because it can provide normal attributes. It can provide combine text. It can also convert values, true or false, and by containing copies of all the list in order for us to operate. We can slice the list and modify it, and again the same operation. I'm not going to go into depth on that, but again I want you to be aware that everything that you do can be modified, and you have full control of what you are applying to. The next type of data container is the integer, and it's used to store a whole number, both positive and negative. You have to declare it as integer in order for it to apply, and by doing that you are applying it. In this case, x is as an integer minus 3, and so in this case it will be equal minus 3, and so you will be able to display the value of 3 as a class x and will define itself as an integer. Again, it's really useful when we will try to understand or break down formulas that ask for integer as part of the formula or the statistical calculation. If the string is also type of displaying text, and so the idea here is I can display text, add numerical value to it, and display it as part of my calculation, as part of what I want to achieve. Character also represent a single element, such as a letter of the alphabet, but it also represent a number, and in order to do that, we have to declare it. So we will declare it x is equal as character, and we will give the value, and we will do that. Again, how to display that. Factor is, again, the idea of going a little bit more in an exploratory variable to multiply and to manipulate. And in R, factors takes a limited number of different values. Example, A, and I will say blonde, black, white, and I will call it a factor. And by doing that, I will be able to display it and be able to display it in a way that I want to find out the attributes. So again, this is the way for me to sort the data that I have in my container in order for me to apply. One of the things that is really important, and I think one of the issues that most of the statistical software do not address, is the idea of false and true. Unable to do that. And so in R, it is the idea of logical variables, and we can have to address them either as true or false. So it is a idea of adding it as additional element to it and to try to see what it holds. So this is small containers that we can apply different techniques of how we want to do. Before I started to teach to work at USF, in the past, we used to write the code to the RStudio or to the R by typing in. We will say first, and we will call read table, and we will set up what location is the table is, and we will define it, and we will say import and type the data. We will also use the same technique to read table from example from a URL or from the web. And so the idea is that you import that, you read the table, you import, and then you ask for a summary. Nowadays, the idea of a data of a file or to upload the file is quite easy. You just go to the file, the bottom window, where you see the packages, plot, and files, and you can import the data, and you can use the data to input into the R. So it's really easy to find and easy to apply to with regard to the data that I'm sure that all of you will experience and applying to it. The last issue that I need also to talk about is GitHub. Most of you did excellent job and started the GitHub and had succeed in it, but it is more than repository service. It is the idea of how to encounter, and the last version of the RStudio is very active with the GitHub, and it allowed us to apply. I will go over the basic code structure, but again, I want you to listen. If you're not going to do the coding of the GitHub, the issue that I want you to pay attention is the idea of activate what you have been working on the file on your desktop, and how to activate that on the repository online. And by doing that, you will have synchronization of the storage and the track in order for you to commit and store the file. And so the file that you're actually working on will have a life circle that will go around and be able to commit and be able to store it online. So there is the idea of modify the files with a working directory. We have the stage, we have the commit, and we can do that in a platform of the code. And if you're not into it, the new version of the GitHub and the RStudio works well. And so the issue is that you will need to commit to what you are doing. An example, the rpers that I did, the package, and I'm just going to refresh it for a second. And so again, the history, compare, and I can do synchronization in order for me to apply, and it doesn't recognize. It can happen. It can happen. Don't be afraid. This is part of learning how to communicate with all those important things and how to apply that. If you are into the code, create a local copy and reopen it. This is the command codes, how to do that. Again, we will work, and I will give you more logs about that. I will show how to do that. The terminology, what is really important is the pulling and pushing, and a good practice is to be aware of those terminology when we are using it and how to branch it. And that's it. I think this is it. You have an assignment of 2 chapters to read. I will give you a small assignment in R that you will start practicing the R and be able to understand what does it entail. Example, we talk about string. My string, and I will say print, and my string hello and print. And again, this is a basic, very similar to HTML, but in R, it's usually with regard to the container, regard to the functions, and regard to what you do. So until next time, I hope you enjoyed this short but introduction to dataset and how to apply and convert it. And if you have any questions, please do not hesitate. Until next time, have fun.